Hey everyone, it's me, Miss B, and in this video we're looking at the Unit 4 Lesson 7 cumulative practice problems for illustrative math geometry. Now, we do have labeled on here that you need a scientific calculator, so please use a scientific calculator for this one. It's going to be difficult if you don't, but that's because we're using sine, cosine, and tangent and those sort of things, but you have to actually use the sine, cosine, and tangent instead of just uh, dividing it. We're gonna yeah, we're just gonna use sine, cosine, and tangent. That's You just need a scientific calculator. If you don't have one, I do recommend Desmos has a scientific calculator. It's desmos.com/scientific. And I particularly like that one when I don't have one nearby, but I do have a good calculator nearby that I enjoy using, so I'm using that one for today. So let's look at our first question. Mai is visiting Paris to see the Eiffel Tower. She's 80 feet away when she spots it. To see the top, she has to look up at an angle of 85.7 degrees. How tall is the Eiffel Tower? So it says for part A, we want to draw a picture of what is described above. So I am not a good artist, but I will try to draw a kind of representation of what the Eiffel Tower would be. I know it kind of has like a shape like this sort of thing. You know what? I'm not even going to try to draw it. We're just going to try to draw the top of the Eiffel Tower, and I'm going to consider that point right there. So when she's 80 feet away, that's going to be a horizontal distance here of 80 feet. So we'll draw, I don't know, my person. Now she has to look up at an angle of 85.7 degrees. Obviously, this is not drawn to scale because the Eiffel Tower is much taller than 80 degrees, or is much taller than 80 feet. So let's draw it a little more to scale and try to draw just a triangle that has an 80-degree angle. So let's draw our 90-degree angle here because we want a right triangle. But we want essentially what's going to be pretty close to 90. So I'm going to draw it mostly like this. So we'll say that like this is the top of the tower, and this is that looks better. Now they did tell us this is a 85.7. That looks like an S. 5.7 degrees here. And then that was my right angle. We want to know how tall it is, so that is going to be this side right here of X. And we did also have she was 80 feet away, so I need to label the 80 at the bottom. That's my picture representation. It's as good as it's going to get. So now set up an equation and solve for the height of the Eiffel Tower. We are going to use sine, cosine, and tangent for this. So we have the angle where Mai is standing. We have the side that is opposite from her, which is the height. And then the side that is adjacent, which is the 80, because we don't have anything. We don't have anything on the hypotenuse. We don't have anything across. We don't know that diagonal distance, and we're not going to need it here. So we do know SOHCAHTOA. So just in case, I'll write it at the top here. SOHCAHTOA. And this is opposite and adjacent, so we're going to use tangent. So tangent with opposite and adjacent, we will say tangent of that degrees, 85.7, should be equal to opposite over adjacent, so x over 80. Now that's the setup. The solve part is to just get x by itself, and we do that by multiplying both sides by 80. What happens here is these cancel. We would just have x left over, and that's going to be 80 times the tangent of 85.7. And so this is what we're going to put into our calculator. So that is going to be tangent of 80. 80 times tangent of 85.7. And my calculator says that x is equal to, this is 1063. I'm trying to decide where I'm going to round to. I'll do 0.97, just 2 digits after the decimal point. And this would be feet, because that is the units we were measuring in. So according to trigonometry, that is going to be the height of the Eiffel Tower. And that's question 1. So let's look at question 2. This one wants us to find all missing measurements, meaning angles and side lengths, of this right triangle. So I'm going to do the one that's easiest here and just solve for the missing angle first, because we have 27 and we have 90. So I'm going to say that angle B is just 90 minus the 27. And so that is 63. That's what I thought. 63 degrees. So we'll put a 63 here. And now we want to find the other two sides of this triangle. So I'll go for AC first. That's the side that's opposite from B as the point. So I'm going to call it lowercase b. And across from the 90-degree angle at capital C, I'll put lowercase c. When you have a triangle like this labeled A, B, and C, it's kind of traditional to label those parts the lowercase versions of the vertex they're across from. See how B points at the side that we're going to call lowercase b. So let's find those lengths. And we're going to stick with the 27. You can use the 63, but I'm going to stick with using the 27-degree angle. So this is the one that I'm just going to use for my degree measurements and stuff here. Okay, so from there, if I want to find B, I'm going to label everything here based on angle A. So 12 would be the opposite. B here is going to be the adjacent, and C is going to be the hypotenuse. So let's find B. Lowercase b, we are going to use opposite and adjacent. So going back to SOHCAHTOA, that is opposite and adjacent. So we are using tangent. So I would say tangent of 27 should be equal to 12 over b. Now we're going to do a couple operations here. You can think of this as a proportion if you want, because there's always a invisible 1, so we could cross multiply. But really we're just going to multiply both sides by b, because that's in the denominator, and we want it to not be in our denominator. So this would create b times tangent of 27 equals 12. And then to get b by itself, we would have to divide everything here by tangent of 27. So those two numbers would cancel each other out, and then here we would just have 12 divided by tangent 27. So ultimately, when we have an unknown variable, or just a variable in the denominator of one of these, we actually are going to kind of have a phenomenon that happens here. So 12 divided by tangent 27 is just the final version of this. You can see I had 12 divided by b originally is equal to tangent, and it's kind of like the b and the tangent 27 just traded places. As you continue to solve more of these problems, you'll find that b and tangent, or just your variable and then your sine, cosine, or tangent function will trade places if your variable begins in the denominator. If you're not super comfortable with that idea, I suggest just showing the work every time. But I'm going to show the work every time because even though I'm comfortable with it, I'm making this video for you and not for me. So let's plug that into a calculator exactly the way it shows. And if you can't plug it in exactly the way it shows, you just want to make sure that everything in your denominator is in parentheses. So that way, if you have more than one thing there, that it actually divides equally. So 12 divided by our tangent of 27 is going to be 23.551. So 23.55. I'll stick with just 55 um, because I did 2 decimal points or 2 digits after the decimal on the previous question also. So that leaves us with one more piece. I guess I'll do this one in like purple or something, so it's still not going to blend in with the rest. We are going to use, instead of tangent, in order to find C is on the hypotenuse. So I'm going to use opposite and hypotenuse because even though I now know a number for B, it's a weird decimal and I did kind of have to round. So I'm going to use the whole number here and use sine, which would give me opposite and hypotenuse because sine is SOH, which is SOH. So opposite over hypotenuse. Let's say sine of 27 is 12 over C. Multiply both sides by C. Divide both sides by sine 27. I'm doing both steps in one because I don't really have a lot of space here, so I'm trying to save a little bit of space. So C is going to end up being 12 divided by sine of 27, and we'll plug that in our calculator. 12 divided by sine of 27, and I get that this is 26.43. I'll put that in a box as well. And there we go. We found our missing angle and our 2 missing side lengths. And so side note, if you are finding that when you plug in sine, cosine, or tangent, that you're getting different answers from me, beyond me just making a mistake, it's also a good idea to check that your calculator is in degrees. Because calculators can be put in degrees or radians, and you might not know even what a radian is, but it's another way of measuring angles that is very different from degrees. And so if you're doing a sine, cosine, or tangent and your calculator is in radian modes, it's going to give you a very different answer. So just look out for that. That brings us to question 3, which is the last one on the front part of this homework. So we have the Gateway Arch in St. Louis, Missouri, and Priya is looking up at a 50-degree angle to see the top. Was it Priya in the first one? No, it's Mai. So Mai is visiting Paris, but Priya is visiting the Gateway Arch in St. Louis. We know that it's 630 feet tall. We want to know how far away she is. So different from Mai, because we knew how far Mai was away. With Priya, we just know how tall the arch is. So I'm going to draw the triangle here. We know that the height of this item is going to be 630. And we know that the angle it should make is going to be about 50 degrees. Now this would be 45 thereabouts. So we're going to scoot it in a little bit more to make the angle larger. I would be comfortable with that being 50 degrees. That is not going to quite be a right angle though. There we go, that looks much better. So this is a 50-degree angle, and then we want to know, reposition this a little better actually, because I didn't realize I needed space to write underneath it. I want to know how far away she is standing from it. And so this is going to be Mai. And Mai is looking at the St. Louis Arch, which is just an archway. So I'm going to draw an arch and maybe, yeah, sure, close enough. I was gonna say maybe my iPad will allow me to do something with it. Let's make it a little taller. There we go. That's a little too tall now, Miss B. We don't need the art in here. Come on, we just want to do the math. Close enough. You get the idea. There's your arch. She's looking at the top of it. Let's actually do the math here. So we want to set up an equation and solve for it. We have everything we need. So 50 degrees is our angle. We're going to label the pieces for my, I'm sorry, Priya. I was in Paris. This is Priya. Um, this one is going to be the adjacent, the leg that is right next to her. And then the leg that's across from her is the opposite. That's the 630. And again, we don't have that measurement for the hypotenuse. So we are just going to use tangent. So we would say tangent because SOHCAHTOA, this is TOA. So tangent is opposite and adjacent. Tangent of 50 degrees, we need to have that degrees number in there, is going to be 630 divided by, and I just called my adjacent length x. We are going to find here that, just like I mentioned in an earlier question, we have our variable in the denominator, so it's going to end up where essentially the tangent of 50 and the x are going to trade places. But I'm still going to show the work for it. And I do have room, so I don't have to do both steps at once. So the x times tangent of 50 is equal to 630. And then we're going to divide both sides by tangent 50. And I do want to stress that one mistake that I've seen some people make is feeling like the tangent and the 50 are separate. It's one thing. It represents one number, so you can't like divide by 50 if that's a mistake that you're making, or if that's something that you're wondering about. The tangent and the 50 are connected, and it's one representation. You can't split them apart from each other. So we divide by the whole expression of tangent 50, and then that leaves us with x is 630 divided by tangent 50, and that is going to be the number. So 630 divided by the tangent of 50 degrees. I find that x is equal to 528. I'm going to round to 2 digits after the decimal, so this is going to be 0.63. And it continues on, it's like 0.63276676, etc., but I don't need to put that. And this was feet. Yeah, feet. So she is 528 feet away when she sees the St. Louis Arch, or from her perspective where she's looking at it. That's the front. So we're going to move on to the back of this page. And then we have questions 4, 5, 6, and 7. Not too bad though. And a lot of these end up being a little bit of review. So based on the figure, which equation is true? So we're going to select all of these that are actually true based on what they give us. And since these are all using 32 as the angles, it is safe for me to use 32 and label the sides as the things that they are: opposite, adjacent, hypotenuse, etc. I don't have to change the way things are labeled there. So I am gonna just highlight a little bit or color in this angle because that's what I'm using. Either that or I draw the little person. Sometimes I do both. Whatever works for you. So opposite is going to be across from it. I find that opposite is sometimes the easiest one to label because it is the line that does not touch the point of your angle. The ones that do touch the point of your angle will always be the adjacent and the hypotenuse, and you can just narrow down which is which by realizing your hypotenuse is the one across from the 90. So we have our hypotenuse here, and then the adjacent would be along the bottom. And we're going to rewrite our SOHCAHTOA statement so that we remember sine is opposite and hypotenuse. Cosine is adjacent over hypotenuse. So ka, and then toa, tangent, is opposite over adjacent. And so now I'm going to use that to make these work. So first off, we have sine of 32. Sine of 32 should be my opposite over the hypotenuse, so 8.5 over x. So that makes this one correct. Not b, which is x over 8.5. And then cosine of 32 is our adjacent over hypotenuse. So adjacent over hypotenuse, we don't have a number for that. So we can't actually even do our adjacent. So there's only one correct answer here, and it is A. And that's kind of true based on the way they worded the problem. They did say which equation is true, not which equations are true. So there should just be one answer, and it's the first one. Sine of 32 is 8.5 over x. That brings us to question 5, with Kieran flying a kite. So Kieran's flying a kite, he gets tired, and he stakes the kite into the ground. Basically, Kieran put the kite in the ground right over here, and then it's flying on this diagonal string. And the kite is on a string that is 12 feet long. That's this one right here. This pink highlight is going to be my string. Oh, it doesn't want to snap nicely. Well, we can just freehand it and it'll kind of make it nicer. There we go. So that's our 12-foot long string, and it makes a 45-degree angle with the ground. We want to know how high is the kite. That is going to be our vertical here. So that's the part we're going to look to find. I'm just going to call that part x. And yeah, we have a couple options with this one because it's a 45-degree angle. I'm going to use what I know about 45, 45, 90 triangles because I realize those are special triangles and I don't necessarily need to use sine, cosine, or tangent to find this because I realize this will also be 45. So that's this will be easier to fit in there, smaller pen. Okay. So what I know that if one side of this triangle is x, the other side will also be x, and the hypotenuse will be equal to x times the square root of 2. So in order to find how high the kite is, which also just happens to be how far away he is from the kite in the horizontal distance, we're going to divide both sides by the square root of 2 because we basically want to solve for x. So I'll actually write this in a different position. So I'm gonna write this over here. So I'm gonna say x root 2 equals 12, and just show my work over here so I'm not crowding my triangle. You want to divide by square root 2. So we would have x is 12 over root 2, but we want to make this into a nice whole number. Honestly, if you get it to this point, that's good. It is always good to what we call rationalize our denominator, meaning make that into a nice number that's easier to imagine us cutting something into pieces. Or just making a rational number out of our denominator, generally a whole number. So we do that by multiplying by the square root of 2, because we can't multiply both sides of our equation by something. We're just going to multiply the numerator and denominator, and that's how this equation is going to keep its same value. So this would then become 12 square root 2 at the top, and the denominator here is just going to become the whole number of 2. And this would actually reduce to be 6 square root 2. And this would be feet. And I'm actually going to plug that in and then give you the decimal equivalent of it as well. And then you could very well just do opposite over hypotenuse. So you could do sine of 45 and use x over 12 for that. But I like going back and practicing things because you're going to need to know how to do all that stuff for your test. So 6 times the square root of 2, and my calculator is going to tell me 6 root 2 because it loves to give me radicals. I press my little exchange button. So this is also 8.49 feet. So I'm going to put my little approximate wiggles there because I am technically rounding that one. So it's less precise. If you're looking for an exact answer, it is going to be 6 root 2. So, and that's why I like doing this as a 45, 45, 90 triangle better than doing sine, cosine, and tangent, because you can get an exact answer instead of just having something that's a decimal that ends up being rounded. Okay, so we only have 2 left. We have 6 and 7. So question 6, we want to match the ratio of side lengths to the corresponding angle measure. Okay. So this is one, because this is a little bit of a throwback to not using sine, cosine, and tangent, to using our table. And technically, you could use a scientific calculator to do this. And you could just realize, oh, adjacent over hypotenuse, that is cosine. And I will type all of these numbers in until I find the cosine of one of them is 0.139. But there's going to be sections on your test where you're not allowed to use a calculator and you do just need to use that table. So I'm going to insert my table over here and we're going to reference that for our answers here. So starting with this, we want to look for adjacent over hypotenuse being 0.139. That to me, 0.1 is right here. So 0.17, this is decreasing as it goes, and 0.139 is actually going to be larger than that. So I don't even know if I have 5 highlighter colors, but I'm going to go for it. A is going to be 82 because it's going to be larger than 80 on my table. So then opposite over adjacent, that is going to be our third column. And we were looking for 0.249, so 0.2. So we have large numbers down here like 5, so we're going to go up until we find 0.2. So 0.3 and 0.1 are right here, which means it should be in between 10 and 20. I only see one number in between 10 and 20, and that is 14. So we're going to select 14 as our answer for B. Okay, let's look at C. C is opposite over hypotenuse, so that is going to be sine. And we're looking at 0.469, so 0.4. So it's decreasing as it goes up. So 0.4 is going to be in between these two here. So that looks like in between 20 and 30. We use yellow. It's a little hard to see, so I might also circle that one because I know it doesn't always turn out great on a screen. And so that is between 20 and 30. That can only be number 2 here, 28. So I'm also going to circle this one in red with a red pen. Just because the yellow's a little hard to see. Okay, so I do have a bluish highlighter color, so that can be the last one. And well, that can be the next one, and then I'll try to find a color for the last one. So adjacent leg divided by hypotenuse, so that is cosine, and that is going to be our first column, and we want 0.682, so 0.64 and 0.76 are going to be the ones that's in between, so between 40 and 50. That's going to be this one here, so let's highlight with this blue. Okay, sorry about that. I don't know why recently, but my computer's had some issues with stopping in the middle of my recording, which is fun. But as I was saying, this has got to be between 40 and 50 because 0.682 is going to fall between these two, which is between Um, sorry, oh, I'm circling the wrong section. Opposite and hypotenuse. This needs to be adjacent and hypotenuse. 0.682 is going to be in between these two, which is in between 40 and 50. That's the one I'm going to highlight as blue. And we're going to check that our last one, or that E and 4, match up. So opposite over hypotenuse, that is the middle column. And we want 0.848. I see 0.86 and 0.766. And this is between 50 and 60. And that does appear where our last value lands. So let's see. Now I have this weird orangish color. It's not really a bright orange, but it's like a weird brown sort of, but hey, whatever works. And those match with each other. So yeah, that's question 6. And the very last question here, we have a right triangle shown. The measure of ABC is the same as the measure of EBD. What is the side length of BE? So let's measure, they gave us ABC and EBD, I think. Yes, they did. So they gave us those two here, already marked as congruent. That's right up here. Both of those angles are marked. And they want to know the side length of which one? BE. So they want to know this part right here. So looks to me like these are going to be angle similarity, because we have a pair of angles that are similar, and they also both have right angles. So we can say that these triangles are going to be similar, and we can use the measurements they already give us, which is 5 and 3, and compare that to 13 and to x. So I'm going to compare just between the same triangle here. So I will say that if I have 5 and 13, that should be the same ratio as 3 over x, because I am doing the leg over the hypotenuse, so that's my pattern here. And then one of these is the large triangle, and the other one is the smaller one. So we're just going to cross multiply. We'll get 5x. And 13 times 3, I believe, is 39, but I'm going to check myself anyways. Yep, it's 39. So not going to come out to a nice whole number, but that's okay. We'll divide here both sides by 5. And we will get 39 divided by 5. You can leave it as 39 over 5, because it's not going to reduce at all. Or 7.8 is the actual decimal, and we don't need to round that. It is just exactly 7.8. So yeah, that is the length of side BE based on that one. And that's going to be it for the homework. So thanks for sticking with me through that. Hopefully this helped you understand anything you didn't quite get. And yeah, this has been the Unit 4, Lesson 7 Cumulative Practice Problems for Illustrative Math Geometry.